Hi everyone, my name is Banu and I work as a network engineer for a telecom company, and I graduated in electrical engineering. I have bachelor's and master's degree in electrical engineering, and the main goal to start this channel is especially for the beginners who are still in their university or who graduated and started their job or looking for the job to get the basic fundamentals on network or the telecom. So I just want to explain them for the in the telecom, like the LTE architecture, voice over LTE, the 5G fundamentals, and also the network, how data packet moves from one computer to the other computer, or you talk your voice on the mobile device. So how the data packets move from one mobile to the other mobile. So it's completely about the network. LTE, voice over LTE, the data packet from one computer to the other computer. So everything is same. Like it's simple. Like I want to start from zero, and let's see how it goes. I just want to touch the fundamentals at least at the beginning, and as we go on, like if you want more to go more technical, I can make more technical videos. But the main it's especially at the beginning, the main goal to start this channel is to start from the zero and just go. And uh, I'll go technical as we go on, but yeah, let's start our video. So I want to start with the OSI model, which explains how a data packet moves from one computer to the other computer, one mobile to the other mobile. It's the best way to explain, like especially to start with. I'll start with the OSI model, and then I'll explain you each layer. I'll go to the network layer first, then transport. But let's start with the OSI model. So yeah, let's begin. S- So you have your computer here. Let's call it's a client, your computer, and you're requesting cnn.com to look at the news, and you're sending a request. I want to browse cnn.com. Your request goes all the way to the CNN server. So it has all the information. So you are requesting, and it sends you the response or the answer with the packets. So we call them the packets. So all your information, all your pages from the server, all your whatever your request is, it sends in small packets, data packets. So you send a request and it sends you a response. And your computer is connected to your the CNN server with wiring. So let's call it a physical wire. So there are many networks in between, or many routers, or many computers in between. Like your CNN.com may be in one country, and your server may be in the other country. But in between these two countries, you have many routers or many networks, sub networks. All these are connected with wiring. So this is called your physical layer. The same way, you have your mobile device. So it's a mobile one, your mobile, and you're talking to your friend on the other mobile. This is your mobile 2. And same way, these are called voice over LTE, voice over IP. It's same data packets. You send data packets and they send data packets, their response. This is a combination of air interface, air, air, to something called tower. We call it RAN technically. and there is a core, LTE core, 5G core. Don't worry about all this, I'll explain each and everything in the detail. Core, your network, so it's a combination of your air interface, your wiring. So this, there comes your first layer in your OSI model, physical layer. Physical layer is it may be Ethernet, you connect to your computer, Ethernet, or fiber, or Wi-Fi, or radio frequencies. See, so physical layer is nothing but how you connect from one computer to the other computer, how the data packets, the medium, that's called the physical layer. Let's go into the next layer called the switching. So the next layer, switching. So now we are done with physical layer. Now comes switching. So I'll try to explain you in it explain you in a simple way. So you have your house, and you have many computers. Like suppose you have three laptops, laptop 1, computer 1, computer 2, computer 3. So you can talk from one computer, you can send a request and a response, like you can send information from one computer to the other computer without any security or without any firewalls. Like uh, from one computer to the other computer, you send the information, and uh, suppose you connect all these through something called switch. So all this wiring, again, this is a physical layer wiring, and this is your something called switch. This is called switching. And these computers talk with each other, like consider them as your family members. Like in your house you have family members, and you talk to your family members each other, and you don't have any layers between your family members, you can talk anything, and there's no firewalls is nothing but your protection. So it's within the same network, so you can talk anything. So that's called switch. Switching has no security protocols or no firewalls. Like you can talk anything with your within your network. With this is your network, this is your house, so one computer can talk to other computer, and they're all connected to a switch. Like I'm trying to explain it in very basic fundamental way. So that's called switching. Like it's your own family, it's your own network in your house. So that there comes switching. And each computer or each network element or each phone or each any network element has uh, its unique name. Like you have your last name, the unique name, like a last name called MAC address. So, so each computer has its own unique name, and it's called MAC address. As you have your last name, it each computer has its own unique name, MAC address, and they talk to each other, they recognize each other by looking at its MAC address. So that's switching. So this computer sends data packet through the switch, and this computer sends the data packet through switch, you looking at the MAC address. So that's your switching. Then we'll go to the next layer, which is your network layer. So we are done with switching. So you have your physical layer, which is your wiring or Wi-Fi, or your radio frequencies. Then you have your switching, which is all the computers within the same network talking to each other, connected to a switch, and they talk to each other using a unique MAC address to that computer or the network element called the MAC address. Then comes the network layer. So let's see what's a network layer. So as I said, in the switching, uh, your computer, your computers within same house or within same network. It's the same network one, let's say. So maybe you can call it, for your understanding, house one, your family members. So your computers, computer one, two, three, talk to each other without any firewalls or without any restrictions within the same network, and they're all connected to a switch, right? So suppose you have network 2, a different house, network 2, and they have computers which are connected to switch, and they talk to each other again. You have network 3, computers, switch, network 4, computers. So these are different networks, and if you want to send up or request something from computer 1 to computer, suppose computer 1 in network 4, uh, then so yeah, if you want to your computer 1 from network 1 want to talk to computer 1 to network 4, then it's a different network, so consider it as a different family. So you have your own restrictions in between. So there comes something called a router in your house, which separates your network from the other network. So this is called a router. So suppose you want to request something, or you want to talk to this computer 1 in network 1 and computer 1 in network 4. So it has to go through this router and then talk to this computer 1 in network 4, or this computer 2 to this computer 3 network 3. Just go to router this way. So network 1 to network 2, always you have something called a router in between. So these routers have their own firewalls. They have all their restrictions which are programmed into it. So if you want to request or talk to from one computer in network one network to other computer in network 2, there is a router in between, and these two computers in different networks send the packets using something called IP address. So here comes IP address. This is switching is MAC address. So MAC address is a unique address. So your phone, your mobile device has a unique MAC address. Your computer has a unique MAC address. But your network address may vary. But it's just like a it's just like a mailbox address. Suppose you are sending a mail from one country to the other country, from one network to the other network. This is how it sends the packet. Like this network has its own IP address. This has its own IP address. I'll explain you about the IP addressing and the network layer in the next classes. Like I'll go into more technical, but yeah, this is the basic. So it has its own IP address, it has its own IP address. Suppose if you want to send a data packet from here this computer to this computer, so you have to send with source IP address, which is this, and the destination IP address, which is this. You have to send the IP source and destination IP address, and the data packet travels from this network to this network. Once the data packet reaches Here then it will look for the MAC address and sends it to its destination computer. So uh, when you're sending a data packet from one network to the other network, the main important thing is it looks for the IP address. Using the IP address, it goes to the respective router. Through the router it goes to its destination network of, and once it goes to the destination network, using the MAC address, the unique MAC address, the data packet reaches the destination computer. So that's how your network layer works. So to put it into the simple words, switching is nothing but your data packet travels within the same network from one computer to the other computer. Like it's like your family members in the same house talking to each other without any restrictions or firewalls. So there's a switch in between you and your family member, your brother or sister. So there is no restrictions or nothing. But if you're talking to someone in the other house, like someone in the other country, completely different house, so there are restrictions, there are routers in between, so you have to pass through the routers. uh, Suppose you are talking from one computer in United States to the computer in China. There are many routers in between, so each router has its own restrictions, so it has to pass through all the routers to get to send its request and get its response. So that's the network layer, to put it in the simple words. And next comes the transport layer. So we talked about physical, which is physical wiring, Wi-Fi, radio signals. Switching, which is you're talking electrical computers talking within the same network. And network layer, so this is your computers talking from one computer to the other computer in different networks, different countries, with routers in between, restrictions, firewalls in between. That's your network layer. So physical layer, wiring, this is Ethernet. uh, Wi-Fi, just to give some examples, switching, MAC address. This is IP address. And this is the next one is the transport layer. Transport. So transport layer is nothing but how you're sending your data packet. So as I said before, you're sending your data packet through a physical layer, which is the air interface or Ethernet or fiber. So this is the physical layer, and switching is whether you're sending your data packet within the same network, and our network layer is if you're sending your data packet to different networks. So switching and the network layer talks about where you're sending the data packet within the network or to a different network. Physical is how you're sending the medium, but the transport layer is uh, how your data packet travels. So suppose uh, this is your computer one, and you are requesting same thing, CNN.com. This is your server, CNN. You're sending a request, I want to get the news, access CNN.com. So the main uh, two protocols of transport layer are TCP, UDP. Let me explain you what's TCP. So TCP is when you're requesting the data packets, as I told you before, they come in small packets. When you're requesting, they come in small packets, and all the small packets combine to give you the news, cn.com. So let me explain you in a simple way the TCP protocol. It's called transmission control protocol. So in the transmission control protocol, it's a reliable protocol where uh, you request the data packet, the server sends the data packet, and one data packet 1, suppose it sends data packet 1, then your computer sends the acknowledgement that it received the data packet. So in this way it's reliable. So suppose if your data packet is missing, and it the computer once sends the server that acknowledgement that I did not receive the data packet, send it again, so it again sends the data packet. So it's reliable. So in this way, all your data packets are received from your server to the computer. If they are not received, the computer one request server again. See, I did not receive the data packet. Send it again. So once all your data packets, data packet one, two, three, all of them are received, they are rearranged again and to give you the news. And this is reliable and secure as the computer requests the server the data packets which are missing. But when it comes to the UDP, let me explain your UDP. So I told the transport layer has TCP, UDP as its main protocols. So TCP, I said, uh, the computer requests server the missing data packets so that the server sends them again. So it's a reliable protocol, and the quality is high, like there's no missing data packet. But it's a little bit slow compared to UDP is a user datagram protocol where it's a very very fast. So computer, your server, it's request some link, and it sends the data packet. So it sends data packet 1, but there is no acknowledgement from computer. It sends data packet 2, it sends data packet 3. So computer server doesn't know whether computer is receiving the data packet or not. It's very fast, and it sends all the data packets without getting any acknowledgement. The real time use of UDP is your voice calls, your video calls. So in your voice calls or video calls, you talk to your friend and your data packets come from one phone to the other phone, and it uses UDP, user datagram protocol. That's why you see sometimes there is a break in the voice, or some even the packets are missed, you don't hear the voice of your friend, and you ask them to repeat it again. That's where user data, it's a real time example where your data packets when they are not received or when they are lost, you hear a break in the voice and you ask your friend to talk again, or something like that. Or if the duplicate voices, if it sends data packets again and again, you hear it twice. Or if when the latency is the time, let me explain you latency again, and I don't want to confuse you, but this is what goes on. Like there is no acknowledgement, like real time video. So from one mobile, you're doing a video call, it sends, you send the data packet and they send the data packet. Suppose if some data packets are missing, there is a disturbance in video, you talk voice calls. If some data packets are missing, you there's a break in the voice and you have to talk again. So that's the real time example of UDP. So real time calls, video calls, TCP. TCP is the reliable protocol, as I said. All your HTTP, HTTPS, FTP, all SSH, all the protocols, reliable protocols use TCP. So there is a proper acknowledgement from the server, and all your data packets from the server to the computer are rearranged in a right manner. So there's a quality, and nothing is missed. But whereas in UDP, it's a real-time protocol. It's a very fast. but it's not secure, and your data packets are missed. But that's fine, because uh, the main use of the UDP is real time calls and video calls. I know Netflix, the real time example where we watch our movies. Netflix, Prime, and everything uses TCP, as they need quality, they don't want any missing packets and all. But your real time calls, video calls video calls, they use UDP. But I guess you can look on the internet. YouTube uses TCP, and some of the cases it also uses UDP, both. So these are the real time examples for your clear understanding. So yeah, you want news from CNN.com, or you are watching a YouTube, or you're watching Netflix, or you're any other way, your HTTPS websites, they're all TCP. I guess this is clear. So TCP UDP protocol's transport layer is how your data packet transfer moves from one device or one computer to the other computer, how it moves. So the physical layer is the medium. The switching layer is if it travels in the same network or the different network. If same network switching, and the different network, it uses router in between with the firewalls as with a secured connection, and from one network to the other network. And transport layer is how it travels. It's a TCP UDP, whether the server sends acknowledgement, or it's a fast way using UDP with no acknowledgement. That's a real time. Then comes your session layer. So let me write everything again. Physical switch, internet transport, then comes session layer. Session layer is nothing but a tunnel which is created. It's a session, it's a tunnel or a session which is created between your client and your computer, your one mobile device to the other mobile device. Suppose as I said before, your computer or your mobile to your server or other mobile device. So to have all this, it has to have a secure tunnel. So the physical layer, let it be wiring or air interface, anything switching. So something has to be created. It has to create a connection between computer or server, or from one mobile device to mobile device. uh, it happens in the session layer. So it creates a tunnel. From there it transfers the packets, whether it's a UDP, TCP, or within the same network or a different network. It is switching using a MAC address. It uses MAC address. It uses IP address if it is a different network. It uses the air interface wiring if it's a physical. But there should be a connection between your computer server, your one mobile device to the other mobile device, secured connection. And it has its own protocols, TLS and all that, which we'll talk in the future sessions about the security protocols. But this is basically what the session layer is. It's a connection between your computer to the server. Then comes your, let me explain you here, presentation layer. So presentation is nothing but uh, on what, like your application is running on. Suppose you are running your YouTube is an application, and your suppose CNN.com or some website on HTTP or HTTPS, those are all applications. uh, you're running your application on a operating system. So there comes the presentation layer, your operating system, where it runs on, it talks about the drivers and everything. So I don't want to talk about presentation layer much here. So it's basically where your application runs on, where your drivers are installed and all that. So that's your presentation layer, and then comes your seventh layer. As I was talking just now, it's a application layer. Application is nothing, layer is nothing but your application, app. What app you're running on, the apps you download, the same thing, the application, your YouTube application, your YouTube. It's where end user gets in touch with, in all the physical, in all the seven layers, the end user uh, has more connection with the application layer, because he uses applications. Everyone uses application, whether it's a YouTube, whether it's a news channel, whether it's a Netflix, whether it's a Prime, whether it's a CNN.com, whether it's anything application. Suppose if you're using a YouTube or CNN, it's a HTTP. You're using a file transfer protocol, FTP. uh, Again, you are using a secure connection, SSH. So all these are your application layers. Application is nothing but what a user uses, the app on Chrome or Internet Explorer, or Firefox. You use your application on your operating system, which is a presentation layer, by connecting a secure tunnel between your computer to the server, the secure tunnel using a session layer, and how your in the tunnel, how your data packets, whether it's a TCP, whether server is sending an acknowledgement or not, or it's a fast protocol, UDP, and internet, whether your tunnel is created between one network to the other network, or is it within the same network using the MAC address, by using a physical layer, the wiring or a interface. So all your connections from one computer to the other computer is explained by these seven layers: the physical layer, the wiring using within the same network or a different network, how reliable is it, how the packets are moving, the fast, slow, reliable, non-reliable, secured or not, session layer, your connection, the tunnel created between the two, what operating system it's working on, the presentation layer, and what application you are using. So it's application you are running can be easily explained by this seven layers, which is your OSI model. So OSI model is also explained by TCP IP. It's the same thing. TCP IP or OSI model is the same thing. These three layers, the first three layers, application, presentation, and session, are combined together to call just the application layer. It has both three: application, presentation, and session layer, transport, network or internet, switching, physical. So TCP IP or OSI model is the same thing. So it has the seven layers. It has five layers. Five layers, seven layers. So I hope I'm clear with my fundamentals. Let me know if you have any questions. I can go more technical into each layer as we go on, but let me know if it's good, if you're able to understand. And if you want me to explain on any other things, but the next class I want to just explain you more technical on internet or network layer. Like I want to explain you everything about this. I want to go more technical. It will take like 7 to 8 classes or maybe 10 classes. So once you get a grip on this layer, network layer, going forward it will be very easy to learn any architecture, whether it's LTE, voice over LTE, or how the data packets move from one network to the other network. It will be very easy once you get a strong understanding of the network layer, how IP addresses are formed, the classes and everything. I'll explain you everything, subnetting, supernetting, everything. But yeah, let me know uh, how this class is, and if you want anything more specifically. Yep. Thank you. I'll see you in the next class.